the load I can suspend. What are these? These are bridges. And the tuning fork which I'm going to use, that some other color. Is I think all of you know tuning fork, some idea? The stem, what happen, will be in contact with this one. So if you look at the tuning fork, they just will have a small discussion on this. How the tuning fork, it will vibrate in this one. So when you hold the tuning fork here and strike, these are called as the prongs, am I right? And this is called like a stem. How the vibrations of this will be, these will vibrate 180 degree out of phase. This will vibrate in this way. Also like prongs will vibrate opposite to each other. Opposite to each other means I think that this will help you in next coming chapter also. That's why let me discuss in detail little bit. This would be prongs. So you try to see this one. No, they are up 180 degree out of phase. What about this? So here the stem, what happen, will be vibrating in this way. So how the stem will vibrate? The stem will vibrate vertically up and down. So I think you are going to hold the stem. Am I right? And these are called as the prongs. So when you strike this to the rubber pad, any one prong you strike it, no, they'll start vibrating in this way. So the prongs will vibrate opposite to each other. They'll have phase of 180 degree. And because of that, the stem, what happened, will vibrate this one. So though we hold the stem, the still what happen, there'll be some vibrations. The stem will vibrate vertically. So the prongs, so here, prongs will vibrate with 180 degree out of phase, and the stem will have vibrations along vertically up and down. There'll be some vibrations will be set up in the stem also. So the stem, how it will vibrate up and down. Okay, got that one. So this particular stem, what happen, I'm going to place on the wire. So what it will do, it will make this wire to vibrate. Are you getting the idea? So how using a tuning fork, I'll make the wire to vibrate. This is a method. Yesterday I had a discussion. No? I'll bring a tuning fork. So one method is like in sonometer, rather than person striking this, with help of tuning fork, I'll make it to vibrate. Then if I bring a tuning fork of frequency, say there's this particular bridge is having a length L, the distance between the this end. So this particular thing will have a mu. What is the fundamental frequency of this wire? These are the bridges. The bridges, what happen, will become like a node. Are you getting this one? This will become a node. So I'll put red color. I'll put a red color. Just if I keep it, no, that is sufficient to make it to vibrate. Then what is the fundamental frequency of this? Let it be 100 hertz. If I bring tuning fork of 100 frequency hertz, then I can see this will have maximum vibration. Able to understand? So here we will have small discussion. So first what will happen? Let the fundamental frequency of this wire, let it be 1 by 2L. T by mu. I adjusted the tension. O will determine tension, the suspended mass. And the mu, I know it. And the fundamental frequency, let it be 100 Hz. If I bring a tuning fork of frequency 100 Hz, now tell me what will happen to this particular loop which is between the bridges. So what are these? These are called as a bridges. They're mobile. So what do we get? I will get a loop. The loop will be like this. I'll get a fundamental one. Agreed. If I bring a tuning fork of 200 Hz, then what do I get? I'll get two loops. Once again, what we discussed yesterday, the same thing is what I'm trying to explain through diagram, because you don't do lab, no, that's why I'm trying to give the information. What is the frequency of tuning fork? Will be 200 Hz. Are you getting now? Like that, sir, I will bring the 300 Hz. Three loops you'll get. Sir, if I bring 150 Hz, what will happen? You don't get, the wire will not have maximum displacement. It will vibrate. What happen? Hardly you can hear sound, or hardly it vibrates here. So we are talking about resonance. Resonance between what? There'll be flow of energy from the tuning fork to the wire only when the frequency of tuning fork becomes equal to resonant frequency. And sir, how do you can say maximum amplitude? I'll keep some small piece of paper. Then, so if I bring a tuning fork of 100 Hz, then what happen? As it vibrates, the paper what happen? The paper what happen will fall off from the wire. And I can, if you are very good, no, you can hear the sound also here. So then a resonance is said to occur. If you bring 50 Hz or 150 Hz, what will happen? One and a half loop? No. The wire will vibrate. What happen? The paper which you get will not fall, and hardly you can hear any sound. So it's of no use, that one. So what is the resonance now? The maximum transfer of energy will occur from tuning fork to the wire between the bridges only when the frequency of tuning fork becomes equal to resonant frequency. Resonant frequency of this wire depends on what? Depends upon tension, depends upon mu, and what is the length between the bridges. Okay, clear this one? So I'll put it here. The maximum tuning fork to wire only when frequency of tuning fork is equal to resonant frequencies of wire. What are resonant frequencies of wire? We know how resonant or harmonic. Which all you feel convenient. Okay, this, so the transfer of energy will take place here. When the tuning fork will deliver maximum energy, when the frequency of tuning fork becomes equal to resonant frequencies of the wire. Okay, this called like the condition here. So now let's do one thing. Here, what I'm going to change, as I change the, no, what shall we write? Shall I write 2? Y2, Y2, because I brought 200 Hz. So the wire will vibrate now in what? Second harmonic. I'll bring 300 Hz. Then what happens? 3 by 12. So what quantities are changing? So here, shall we put F proportional to N? As I bring 100, 200, 300. So what happened to number of loops? Number of loops will keep on changing. No? So what quantities are kept constant? L is constant. T is constant. Okay, can I do that in sonometer? Yes, it is possible. Please do make observation. The first condition is what? F proportional to N is what I have shown here now. Now I'll keep F constant. Then as I vary length, what will happen? or I'll keep F constant as a vary tension, then what will happen? That we are going to see it. This is what our the string which we are discussing. No, we are not. Don't bother, sir. Like, will it vibrate or not? The wire between the bridges has to be vibrated here. Okay, there's the first case what you have seen. Second situation, I'll write it here. There's the first part, sonometer. Second case, I'll take the same diagram. Now, F I'll maintain constant, then I'm going to change L. Then we'll see what conditions will get it. We'll write second case. What is the second case? Second case says that F constant, then then what conditions will arise. So first case I should write it no here. L constant, T constant, then F is proportional to N. That's what we ended up. Second situation, F is kept constant. Then I'm going to vary the L line and T also let me keep constant. Now what shall I do? Now let me keep this F. If I vary L, then what conditions should come? I'll directly go for I'll attack the formula. What we have, F equal to N 2L by T mu. No, F and T are kept constant. So what is varying now? As you vary the length, N should change. So if N increases, what should happen to L? Anybody wants to answer here? Should increase so that the F under root of T by mu should be constant. So for a length L, if I get two loops, for 2L, what I should get? Or for 3L by 2, what I should get? I should get the 3 loops. I'm trying to explain everything through diagram. In books, it is given just only the explanation so that students it will be very easy for you to understand this one. Huh? Okay, let me do no. I have to show 2 loops, no? So what is the length? Length will be how much? 3L by 2. L by 2 off loop, L by 2 off loop, 3L by 2. So what is the quantity we are going to vary now? Here F, T are constant. As N varies, L will vary. So therefore N will be proportional to N. I can also do like this. Okay, got the idea? This one. Next again, what we do is like we'll keep F and L constant. As I vary tension, then we'll see what will happen to N. The third situation. F constant and L constant. N and T are variable. How to vary tension? Anybody can you suggest how to vary tension? Let me go for more number of loops. So it will be easy for you because only 1, 2 loop, you'll get confused. So initially there are In books, if you see, no, this called like a law of tension, law of length, well, like that. In SERMA, you have explained. I'm giving suitable diagram. Okay, the length L will be constant. The length of the bridges, the distance between bridges will be fixed here. Now here, I'm going to vary tension. So earlier, this having a mass m1. Let's assume that one. The tension is T1. There are n1 number of loops are there. I will increase the load. How to increase the load? I'll add one more mass. The tension will become now the T2 M2G. This is T2. This is T2. Now omni loops are there. Now come from here. And then increases, what will happen to tension? Should decrease, no? If I increase tension, N should decrease here. So how many loops are there? One, two, three, four, five, six. I'll say that M2 M2 less than M1. M2 less than M1. If M2 less than M1, then tension, what will happen? Earlier it was T1 N1. Now how much it will be? F is equal to N2 2L T2 by mu. So what is the equation we have? N1 T1 is equal to N2 T2. T1 is equal to M1G. T2 equal to M2G. So T2 less than T1. T2 less than T1 means N2 should increase. So I should increase the number of loops. So don't increase the length between the bridges. Earlier 6 loops are there, no? So it will become 7 loops. Or it can be more than count. Okay, 7 are there. The frequency F is not changed. I'm just changing the number of loops here by using this method. How to decrease the tension, or you can just immerse this particular block in a liquid, no? Definitely tension decrease. Or I'll suspend another block which will have mass less than the M1. This called like a law of like a here tension, here law of length, law of frequency. Here F is maintained constant. So like here the frequency is changed. F is proportional to N, law of frequency. Here length is what? We are changing law of length. Here tension is varying, law of tension. So in the SEORMA book, what he has explained clearly. The sonometer experiment, I shown all everything. They may ask you this elaborate question: how the tuning fork should be kept? The stem should be in contact with the wire at one of the bridge. You should not connect the wire to this one. Huh? So there's a sonometer experiment here. We can also change mu and we can relate F. It's there in our material. One question is there, but these are the experimental things what we usually do in the lab. Now, can I use this to find out the find out the frequency, or so like the density of material? Some say there's some solid there whose density have to be determined. Can I take help of this one? Yes. So there is a we have a string. I'll use this experiment to determine the density of a substance. So